Hi, in this video we will learn how to use MATLAB to analyze pictures. Potential applications of this is to analyze the results of a CFD simulation and turn it from a visual result into a quantifiable result. The way MATLAB creates and analyzes pictures is as multidimensional arrays, or a 3D matrix. The matrix has three layers, one for red, one for green, and one for blue. The final picture is a result of these three layers combined. Now each pixel within a layer can have a color range between 0 and 255, where 0 represents black and 255 the color would be most present. To demonstrate this, let's look at this simple script of code. The variable photo was created for our picture. Then we use the function 0 to create a matrix with the height of 500, width of 500, and depth of 3. Now this function will set all the pixels to 0, which means that the picture we will get will be completely black. If we run this code, let's see what we get. As you can see, we got a picture with 500 by 500 pixels and they're all black. Now let's change the colors of the picture. We'll write our variable photo, and in between parentheses we'll index the first layer, which represents the red. The columns here means that this applies to all the pixels in the image. So let's set the red at 255, which is the maximum level, and keeping the green and the blue at 0. Let's run this code and see what happens. As you can see, our image is now all red because the layer for red is at maximum level. If we want to mix colors and say add green to the picture at 150, now our image is yellow because it's composed of red and green. Now my goal is to analyze a picture. I want to count the number of red pixels in this picture. This has a resolution of 1200 by 1200 pixels. First, I need to import that picture into MATLAB. I've created the variable photo for my picture, and then I will use the function imRead and put the name of my image in here. Now the image needs to be in the same file where the program is saved at. After that, I will just use the function imShowPhoto to show this photo. Now to look at each individual pixel in this photo, I can go to Tools and then use Data Tips to analyze individual pixels. Now if I press on the black section, as you can see, the RGB color composition is all at 0. If I put it on the red, the RGB for red is 237, for green it's 28, and for blue it's 36. I will write that down because this will be useful when I'm writing my code. After I've imported the picture into the program, I want to create variables to represent the dimensions. I'll create an empty matrix with three variables, h representing the height, w representing the width, and d representing the width. And then I will use the function size, and between parentheses, I will put the name of the variable for the picture, which is photo. When I run this code, as you can see in my workspace, the three variables are corresponding to the dimensions of the picture. Now I want my code to iterate through each individual pixel in the picture and then test if it's red or not. To do so, I'll create two for loops. My first loop will have the variable ii, and I want to start from 1, jump by 1 until it reaches the height. This will cover the entire picture vertically. I'll create another loop within this loop to iterate horizontally. So I'll have another variable jj, and I want it to iterate from 1, jump by 1 until it reaches the width. And now I have to close my loops. Now these two loops will simply have numbers increase from 1 all the way up to h, which is 1200, and up to w, which is also 1200. After that I have created my loop, now I want to test each individual pixel of whether it's red or not. To do so, I'll use an if statement. So I'll create an if statement and then close it. And here I can put the condition I wanted to test for. So first of all, I need to write down the variable. And now we need to write an index that refers to each individual loop. And since my two for loops go from all the way from 1 to 1200, I could put these variables inside the index. So II and JJ, and then 1, which means I'm referring to the red layer here. Now, if you can remember from the data tips, this is the RGB composition of the red color in this photo. So I will use these numbers in my if statement. Now, since the number 1 here represents the red, all pixels that have a red composition, I want them to be included in the statement. So I will put if the pixel in the red layer is greater than 0. So the green color composition for the red pixels from the data tips was 28. So I will test for every green layer that is less than or equal to 28. Now we move on to blue. So also I want it to be tested for simultaneously, so I will add and then I will index the blue, photo, II, JJ, and then 3. And the blue color composition for red and from the data tips was 36. So I will put if blue is less than or equal to 36. My goal was to count the number of pixels that are red in the picture. So I will create an empty variable before the loop and I will name it counter, and I will equate it to 0. I'll go back inside the if statement. I want that every time this if statement is correct, which means the pixel is red, I want my counter to increase by 1. To do so, I will simply write counter will equals counter plus 1. So this code will iterate through each individual pixel in the picture. And then if it detects a red pixel based on the conditions that I have set in my if statement, then my counter will increase by 1. So if I run this code, now I have a value for counter, which is the number of pixels that were detected. I want to represent the number of red pixels as a percentage of the entire amount of pixels in the picture. To do so, I will create a simple math formula to calculate the entire number of pixels. So I'll name a variable total. This will equal height multiplied by width, which will give me the entire amount of pixels. So then I will divide the number of red pixels by the total. So I will create a variable called percentage, and this will equal the number of red pixels, which is the variable counter, divided by total. And then I will multiply this by 100. Finally, I want my code to print a statement that shows the percentage of red pixels. So I'll use the function fprintf. And in between quotations, I will write my statement. So I want to say percentage of red pixels is, and then I'll write %g. So the %g is going to be the placement of my variable. Then I'll write a comma, and I'll write my variable, which is percentage. And I will close the function. So when I run this code, as you can see here, it printed out the percentage of red pixels. This was a submission by the University of Florida. Thank you for watching.